What if our civilization is not the first? What if humanity has built and fallen, risen and vanished again and again, each time forgetting the world that came before? The question hangs in the air like morning mist over ancient ruins. It whispers through the corridors of museums where stone tablets bear witness to empires that crumbled into dust. It echoes across desert plains where cities once thrived, now buried beneath sand and silence. And it lingers in the deepest parts of our collective memory. That strange feeling we sometimes get when standing before something impossibly old. A sensation that we've been here before, that this story has already been told. We like to think of human history as a steady climb upward, from caves to cities, from stone tools to smartphones, from darkness into light. The narrative we've been taught is linear, progressive, inevitable. We are the pinnacle, the culmination of everything that came before. But what if that story is incomplete? What if the line we've drawn through time is actually a circle, or perhaps a spiral, turning and returning, rising and falling in patterns we've only begun to recognize? Tonight, we're going to explore a possibility that challenges everything we think we know about our place in time. We're going to walk through the evidence, archaeological, geological, mythological, that suggests humanity's story might be far older, far stranger, and far more cyclical than the history books admit. We're going to ask questions that have no easy answers, and we're going to sit with the uncomfortable possibility that we are not the first to reach for the stars, not the first to build great monuments, not the first to believe we had conquered nature itself. And perhaps most unsettling of all, we're going to consider whether we're approaching another turning point, another reset, another moment when everything we've built might slip back into the earth, waiting to be rediscovered by whoever comes after. The story begins not with answers, but with anomalies, with things that shouldn't exist, in places they shouldn't be, built by people who supposedly lack the knowledge to create them. It begins with the uncomfortable realization that the deeper we dig into the past, the less certain we become about what we thought we knew. Beneath the surface of the Mediterranean Sea, off the coast of what is now Greece, divers discovered something that shouldn't have been there. The Antikythera mechanism, pulled from a Roman shipwreck in 1901, looked at first like a corroded lump of bronze and wood. But as researchers carefully cleaned and examined it over the following decades, they realized they were looking at something extraordinary, a device of such sophisticated engineering that nothing comparable would appear in human history for another 1,000 years. The mechanism was an astronomical calculator, a machine of bronze gears and dials that could predict the positions of the sun, moon, and planets with remarkable accuracy. It could forecast eclipses. It tracked the ancient Olympic Games. The level of miniaturization, the precision of the gear teeth, the complexity of the differential gearing, all of it spoke to a technological sophistication that seemed impossible for the ancient world. When scientists finally created X-ray scans and digital reconstructions of the device, they found themselves staring at what one researcher called an ancient Greek computer. But here's what makes the Antikythera mechanism so unsettling. It appears suddenly in the archaeological record, fully formed, with no apparent predecessors. There's no gradual evolution of simpler devices leading up to it. It's as if someone handed the ancient Greeks a piece of advanced technology. They built this one example, and then the knowledge vanished. The Romans who salvaged goods from the shipwreck had no idea what they were looking at. By the time the device sank to the bottom of the sea, the knowledge of how to build it had already been lost. This pattern, advanced knowledge appearing suddenly and then disappearing, repeats itself throughout the archaeological record, and it raises a question that archaeologists have struggled with for generations. If ancient peoples could create something this sophisticated, what else were they capable of? And more importantly, what else did they create that we haven't found yet, or that we've found but failed to recognize? The Mediterranean holds other secrets. Beneath the waters off the coast of Alexandria, divers have mapped the remains of Cleopatra's palace, swallowed by the sea after earthquakes and rising waters claimed the ancient shoreline. Off the coast of India, near the city of Dwarka, underwater archaeologists have discovered structures that appear to be the remains of a large settlement, submerged beneath the waves. The dating is controversial, but some researchers suggest these ruins could be far older than conventional history allows. And then there's Yonaguni, off the coast of Japan. In 1987, a dive tour operator discovered massive stone structures beneath the waves, terraces, steps, pillars, and what appeared to be carved faces staring up through the blue water. The formations are enormous, geometric, and deeply puzzling. Mainstream geologists argue they're natural formations shaped by erosion and tectonic activity, but others point to features that seem too precise, too regular, too purposeful to be accidents of nature. The debate continues, but the structures remain silent and enigmatic beneath the Pacific. What's striking about these underwater discoveries is not just their existence, but their implication. If these are indeed human-made structures, they were built when the sea level was much lower than it is today, and that means they're old, far older than the civilizations we learn about in school. The last time sea levels were significantly lower than they are now was during the Ice Age, which ended roughly 12,000 years ago. If humans were building cities and monuments during that time, it would mean our story begins much earlier than we've been taught. But the ocean floor isn't the only place where we find evidence of lost worlds. Sometimes the Earth itself opens up and reveals what it has been hiding. In 1963, a man in the Derinkuyu district of Turkey was renovating his home when he knocked down a wall and discovered a room he didn't know existed. Behind that room was another, and another, and another. What he had stumbled upon was the entrance to an enormous underground city, carved directly into the soft volcanic rock. The city descended multiple levels deep into the earth, with tunnels connecting thousands of rooms, living quarters, storage areas, stables, churches, and even schools. Ventilation shafts brought fresh air to the deepest levels. Stone doors, massive circular wheels of rock, could be rolled into place to seal off sections of the city from invaders. Derinkuyu could house up to 20,000 people, along with their livestock and food supplies, and it wasn't alone. Archaeologists have since discovered dozens of similar underground cities in the Cappadocia region, all connected by miles of tunnels. Some researchers believe these cities were built as refuges, places where entire populations could retreat during times of invasion or catastrophe. But the question remains, what were they hiding from? What threat was so severe that it required the construction of entire cities beneath the earth? The conventional explanation is that these cities were built by early Christians fleeing Roman persecution, or by local populations seeking shelter from Arab raids. But some of the cities show evidence of being much older, with layers of construction and modification spanning thousands of years. And the scale of the engineering, the planning, the labour, the sheer determination required to carve these spaces from solid rock, suggests a level of organisation and purpose that goes beyond a temporary refuge. What if these underground cities were built in response to something catastrophic? What if the people who carved them into the earth were survivors of an event so devastating that they felt the only safe place was deep below the surface? And what if that event was not unique, but part of a pattern, a cycle of destruction that has repeated itself throughout human history? The earth bears scars. Layers of sediment tell stories of sudden floods. Ash deposits mark the eruptions of supervolcanoes. Impact craters, some of them massive, record the moments when objects from space collided with our planet. And in many places around the world, archaeologists have found what they call destruction layers, thin bands of ash, charcoal and debris that mark the sudden end of settlements and civilizations. One of the most famous destruction layers is the one that marks the end of the Bronze Age, around 1200 BCE. Within a span of just a few decades, Nearly every major civilization in the Mediterranean and Near East collapsed. The Mycenaean palaces of Greece were burned and abandoned. The Hittite Empire vanished. Cities across the Levant were destroyed. Trade networks that had connected the ancient world for centuries simply stopped functioning. Scholars call it the Bronze Age collapse, and despite decades of research, no one can fully explain what caused it. Some blame invaders, the mysterious sea peoples mentioned in the Egyptian texts. Others point to drought, famine, or earthquakes. But the collapse was so widespread, so sudden, and so complete that it suggests something more than just war or bad weather. It suggests a systemic failure, a cascading series of catastrophes that brought down the entire interconnected world of the Bronze Age. And when it was over, much of the knowledge and technology of that era was lost. Writing systems disappeared. Artistic traditions ended. For centuries afterward, the Mediterranean world entered what historians call a Dark Age, a period when civilization seemed to take several steps backward. But what if the Bronze Age collapse wasn't unique? What if it was just the most recent example of a pattern that has repeated itself many times before? In the highlands of southeastern Turkey, on a barren hilltop called Gobekli Tepe, archaeologists uncovered something that rewrote the story of human civilization. The site consists of massive stone pillars, some weighing up to 20 tons, arranged in circular formations. The pillars are carved with intricate reliefs, animals, abstract symbols, and humanoid figures that seem to dance across the stone. The craftsmanship is extraordinary, the artistry sophisticated, the scale monumental, and it's 12,000 years old. Gobekli Tepe predates Stonehenge by 6,000 years. It predates the pyramids of Egypt by 7,000 years. It was built before the invention of agriculture, before the domestication of animals, before the development of pottery or metalworking. According to everything we thought we knew about human history, the people who built Gobekli Tepe should have been small bands of hunter-gatherers, living hand to mouth, focused entirely on survival. They shouldn't have had the organisation, the resources, or the motivation to quarry, transport, and erect massive stone monuments. And yet they did. The discovery of Gobekli Tepe forced archaeologists to reconsider the entire narrative of human development. For decades, the story went like this. First came agriculture, which allowed people to settle in one place. Settlements grew into villages, villages into towns, towns into cities. With surplus food came specialization. Some people could become craftsmen, priests, or builders instead of farmers, and with specialization came the ability to create monumental architecture and complex societies. But Gobekli Tepe reverses that sequence. Here was monumental architecture built by people who were still hunter-gatherers. Here was evidence of organized labor, artistic vision, and symbolic thinking appearing thousands of years before agriculture. Some researchers now believe that the construction of sites like Gobekli Tepe might have actually driven the development of agriculture, that the need to feed large groups of workers gathering for ritual purposes led to the domestication of plants and animals. But there's another possibility, one that's more controversial and more unsettling. What if Gobekli Tepe isn't the beginning of civilization, but a remnant of something older? What if the people who built it were carrying forward knowledge from an earlier time, preserving traditions and techniques that had been passed down through generations? The site was deliberately buried around 8,000 years ago. The builders filled in the circular structures with debris, covering the pillars and preserving them beneath the earth. Why would they do this? Why would people invest so much effort in creating something magnificent, only to bury it and walk away? Some archaeologists suggest it was a ritual act, a way of closing one chapter and beginning another. But others wonder if it was an act of preservation, a way of protecting something sacred from a catastrophe they saw coming. Gobekli Tepe is not alone. Across the world, archaeologists have discovered other sites that challenge our understanding of early human history. In Peru, the ruins of Caral date back nearly 5,000 years, making it one of the oldest cities in the Americas. The site shows evidence of sophisticated urban planning, monumental architecture, and complex social organization, all appearing suddenly, with no apparent precursors. In Malta, the megalithic temples of Gantija and Haga-Kim were built more than 5,000 years ago, using massive limestone blocks fitted together with remarkable precision. The temples are aligned with astronomical events, suggesting their builders had detailed knowledge of the movements of the sun and stars. And like Gobekli Tepe, they appear suddenly in the archaeological record, fully formed, with no gradual evolution from simpler structures. In Egypt, the Great Pyramid of Giza stands as perhaps the most famous example of ancient engineering that seems to exceed what should have been possible. Built around 4,500 years ago, the pyramid consists of approximately 2.3 million stone blocks, some weighing as much as 80 tons. The blocks are fitted together with such precision that a piece of paper cannot be inserted between them. The pyramid is aligned almost perfectly with true north, with an accuracy that wouldn't be matched until the invention of modern surveying equipment. And despite decades of research and countless theories, no one can definitively explain how the ancient Egyptians accomplished this feat with the tools and technology they supposedly possessed. What's particularly intriguing about the Great Pyramid is that it represents the pinnacle of pyramid construction in Egypt. The pyramids that came after it were smaller, less precise, and less sophisticated. It's as if the Egyptians reached a peak of engineering knowledge and then lost it, with later generations unable to replicate what their ancestors had achieved. This pattern, a sudden peak followed by decline, appears throughout ancient history, and it raises uncomfortable questions about the nature of progress and the fragility of knowledge. But perhaps the most mysterious aspect of these ancient sites is not their construction, but their purpose. Why did people across the world, separated by vast distances and thousands of years, feel compelled to build massive stone monuments? What were they trying to achieve? What were they trying to preserve? Some researchers believe these sites were temples, places of worship where ancient peoples gathered to honor their gods. Others suggest they were astronomical observatories, tools for tracking the movements of celestial bodies and marking the passage of time. Still others propose they were centers of learning, repositories of knowledge where priests and scholars preserved the wisdom of their age. But there's another possibility, one that appears again and again in the myths and legends of ancient cultures. What if these monuments were meant to survive? What if they were built to last through catastrophes, to serve as markers and messages for whoever came after? What if they were humanity's way of saying, "We were here, we knew things, we built this so you would remember"? The stories are everywhere, woven into the fabric of human culture like threads in an ancient tapestry. Every civilization, every culture, every corner of the world has its version of the same tale. There was a world before this one, and it ended in catastrophe. In the Bible, it's the story of Noah and the flood. God, seeing the wickedness of humanity, decides to wipe the slate clean. Noah builds an ark, saves his family and pairs of animals, and when the waters recede, the world begins again. The story is familiar, told in Sunday schools and children's books, often reduced to a simple moral tale. But the biblical flood is just one version of a story that appears in cultures that had no contact with each other, no way of sharing their myths across oceans and continents. In ancient Mesopotamia, the Epic of Gilgamesh tells of Utnapishtim, who survives a great flood sent by the gods to destroy humanity. The parallels to the Noah story are striking. The divine warning, the construction of a boat, the saving of animals, the sending of birds to find dry land. But the Mesopotamian version is older, written down thousands of years before the biblical account. In ancient Greece, the myth of Deucalion and Pyrrha describes a flood sent by Zeus to punish humanity for its corruption. Deucalion, warned by his father Prometheus, builds a chest and survives the deluge. When the waters recede, he and his wife repopulate the earth by throwing stones over their shoulders, which transform into people. In Hindu tradition, the Matsya Purana tells of Manu, who is warned by a fish about an impending flood. Manu builds a boat, and the fish, revealed to be an avatar of the god Vishnu, tows the boat to safety. When the flood subsides, Manu becomes the progenitor of the new human race. The Hopi people of North America speak of multiple worlds that came before this one, each destroyed when humanity fell out of balance with nature. The first world was destroyed by fire, the second by ice, the third by flood. We now live in the fourth world, and the Hopi prophecies warn that this world too will end if humanity does not change its ways. In Chinese mythology, the story of Gun Yu describes a great flood that covered the earth. The hero Yu spent years controlling the waters, creating channels and rivers to drain the flood and make the land habitable again. His success in taming the waters led to the founding of the Xia dynasty, the first dynasty of ancient China. The Maori of New Zealand tell of Taihaki, who climbed to the heavens and brought down knowledge to humanity after a great flood. The Aboriginal peoples of Australia speak of a time when the seas rose and swallowed the coastal lands, forcing their ancestors to retreat to higher ground. The Aztecs believed in a series of 5 suns, each representing a world age that ended in destruction, by jaguars, by wind, by fire, by flood. The consistency of these stories is remarkable. Cultures separated by oceans, by thousands of miles, by thousands of years, all tell the same basic tale. The world was destroyed by water, a few survived, and humanity started over. Mainstream scholars explain this as a natural result of human experience. Floods are common disasters, and it makes sense that cultures would develop myths to explain and cope with them. But the scale of the floods described in these myths is not local or regional. These are world-ending deluges, catastrophes that wipe out entire civilizations and force humanity to begin again from scratch. What if these myths are not just stories? What if they're memories, passed down through countless generations, of real events that reshaped the world? Around 12,000 years ago, the last ice age came to an end. For roughly 100,000 years, much of the northern hemisphere had been covered in ice sheets thousands of feet thick. Sea levels were hundreds of feet lower than they are today, exposing vast coastal plains that are now underwater. The climate was colder, drier and harsher, and then, relatively suddenly in geological terms, the ice began to melt. The melting wasn't gradual or steady. Evidence suggests it happened in pulses, with periods of rapid warming and catastrophic flooding. As the ice sheets collapsed, enormous volumes of meltwater poured into the oceans, raising sea levels by hundreds of feet over the course of just a few thousand years. Coastal settlements, if they existed, would have been inundated. River valleys would have flooded. Entire landscapes would have been transformed beyond recognition. One of the most dramatic events of this period was the draining of Lake Agassiz, a massive glacial lake that covered much of central North America. Around 8,400 years ago, the ice dam holding back the lake suddenly failed, releasing a volume of water equivalent to all the Great Lakes combined. The flood was so enormous that it likely disrupted ocean currents and caused a brief return to Ice Age conditions in parts of the Northern Hemisphere. This event, known as the 8.2 kiloyear event, left clear markers in ice cores and sediment layers around the world, but there's evidence of even more dramatic flooding. Some researchers point to what they call the Younger Dryas impact hypothesis, the idea that around 12,800 years ago, a comet or asteroid broke apart in the atmosphere and rained debris across North America and Europe. The impacts would have caused massive wildfires, triggered the collapse of ice sheets, and led to rapid climate change. The hypothesis is controversial, and many mainstream scientists dispute the evidence. But proponents point to a layer of sediment found at sites across North America that contains high concentrations of platinum, nanodiamonds, and other materials consistent with an extraterrestrial impact. Whether or not the impact hypothesis is correct, There's no doubt that the end of the Ice Age was a time of dramatic environmental change. And if humans were living in coastal areas during this period, which seems likely given that coastlines offer abundant resources, then entire populations would have been displaced by rising seas. Their settlements would now be underwater, their stories preserved only in myth. But the flood myths speak of more than just rising water. They speak of divine judgment, of humanity being punished for its transgressions, of a world that had become corrupt and needed to be cleansed. This moral dimension appears again and again in the stories, suggesting that the catastrophe was not just a natural disaster but a reckoning. What if the myths are telling us that there was a civilization before the flood, a society that had reached a certain level of development and then fell? What if the survivors of that civilization passed down stories of what had been lost, stories that eventually became the flood myths we know today? This brings us to one of the most famous and controversial lost civilizations in human mythology, Atlantis. The story of Atlantis comes to us from the Greek philosopher Plato, who described it in two of his dialogues, Timaeus and Critias, written around 360 BCE. According to Plato, Atlantis was a powerful and advanced civilization that existed 9,000 years before his time. The Atlanteans had built a magnificent city on a series of concentric islands, with elaborate canals, temples, and palaces. They possessed advanced technology and military might, and they had conquered much of the Mediterranean world. But the Atlanteans grew arrogant and corrupt. They abandoned virtue in pursuit of power and wealth. And so the gods decided to punish them. In a single day and night of catastrophe, Atlantis was swallowed by the sea, disappearing beneath the waves and leaving no trace behind. For centuries, scholars have debated whether Plato's account was meant to be taken literally, or whether it was simply a philosophical allegory, a cautionary tale about the dangers of hubris and moral decay. Most mainstream historians lean toward the latter interpretation, arguing that there's no archaeological evidence for a civilization matching Plato's description, and that the story was likely inspired by real events, such as the volcanic eruption that destroyed the Minoan settlement on Santorini, but embellished and transformed into myth. But the story of Atlantis has proven remarkably persistent. Over the centuries, countless explorers, researchers, and enthusiasts have searched for the lost continent, proposing locations ranging from the Mediterranean to the Caribbean to Antarctica. Some have suggested that Atlantis was located on the Mid-Atlantic Ridge, a chain of underwater mountains that runs down the centre of the Atlantic Ocean. Others have pointed to the Azores, the Canary Islands, or the coast of Spain as possible sites. What makes the Atlantis story so compelling is not just the idea of a lost civilization, but the suggestion that this civilization was advanced, that it possessed knowledge and technology that was lost when it fell. Plato describes the Atlanteans as having sophisticated engineering, organized government, and powerful military forces. If such a civilization existed and was destroyed, what knowledge went down with it? What discoveries, what innovations, what understanding of the world was lost beneath the waves? And Atlantis is not the only lost continent in human mythology. In the Pacific, legends speak of Mu or Lemuria, a vast land mass that supposedly existed before it sank beneath the ocean. The idea of Lemuria originated in the 19th century as a scientific hypothesis to explain the distribution of lemurs across Madagascar, India, and Southeast Asia. Scientists proposed that a land bridge or continent must have once connected these regions, allowing the animals to spread. The hypothesis was later disproven by the theory of plate tectonics, but the idea of a lost Pacific continent persisted in esoteric and mystical traditions. Theosophists and other spiritual movements embraced the concept of Lemuria, describing it as the home of an ancient and spiritually advanced civilization. According to these accounts, the Lemurians possessed psychic abilities and lived in harmony with nature before their continent was destroyed by volcanic eruptions and earthquakes. Survivors supposedly fled to other parts of the world carrying their knowledge. With them, and influencing the development of later civilizations. While mainstream science dismisses Lemuria as pseudo-history, the legends raise interesting questions about the Pacific. The ocean floor in this region is dotted with seamounts, underwater mountains that were once islands before sea levels rose or volcanic activity ceased. Could some of these seamounts have been inhabited in the distant past? Could there be ruins beneath the waves, waiting to be discovered? In the Indian Ocean, similar legends speak of Kumarikandam, a lost continent that was supposedly the home of an ancient Tamil civilization. According to Tamil literature, Kumarikandam was gradually swallowed by the sea over thousands of years, forcing its inhabitants to migrate to the Indian subcontinent. While there's no geological evidence for a large continent in the Indian Ocean, sea levels did rise significantly at the end of the Ice Age, and it's possible that coastal settlements were inundated. What's striking about all these legends, Atlantis, Lemuria, Kumarikandam, is that they describe not just lost lands, but lost civilizations. They speak of societies that had achieved a certain level of development before being destroyed by natural catastrophes, and they suggest that the survivors of these civilizations carried their knowledge to other parts of the world, influencing the cultures that came after. This idea that advanced knowledge was passed down from an earlier age appears in many ancient traditions. The Egyptians spoke of the Zep Tepi, the first time, a golden age when the gods walked among humans and taught them the arts of civilization. According to Egyptian mythology, the god Thoth brought writing, mathematics, astronomy and medicine to humanity. The pyramids and temples were said to be built according to knowledge from this earlier age, preserved and passed down through generations of priests. In Mesopotamia, the Sumerians told of the Apkallu, 7 sages who emerged from the sea before the flood and taught humanity the skills of civilization, agriculture, architecture, writing and law. After the flood, the knowledge of the Apkallu was preserved by priests and scribes who continued to pass it down through the generations. In South America, the Inca spoke of Viracocha, a bearded god who appeared after a great flood, and taught the survivors how to build, farm and organize society. Similar stories appear among the Maya and Aztec, who spoke of Quetzalcoatl, the feathered serpent god who brought knowledge and culture to humanity. These myths share a common theme. Knowledge came from somewhere else, from an earlier time or a divine source, and was preserved through catastrophe. The implication is that civilization did not develop gradually from scratch, but was jump-started by wisdom inherited from the past. But if there were advanced civilizations before recorded history, why haven't we found more evidence? Why aren't there ruins and artifacts scattered across the landscape, clear proof of these lost worlds? The answer might lie in the nature of time and the fragility of human creations. Imagine a city. Not just any city, but a great metropolis, skyscrapers of glass and steel, highways threading through concrete canyons, millions of people going about their lives. Now imagine that city abandoned. No maintenance, no repairs, no human presence at all. What happens? Within a few years, the roads begin to crack as water seeps into the pavement and freezes, expanding and breaking the surface. Vegetation takes root in the cracks, and within a decade, trees are growing through the streets. Buildings, no longer heated or cooled, begin to deteriorate. Windows break, allowing rain and wind inside. Mold spreads across walls. Metal corrodes. Wood rots. Within a century, most of the buildings have collapsed. The steel frames rust and buckle. The concrete crumbles. The glass shatters and is ground into sand. Rivers reclaim their old courses, flooding areas that were once dry. Forests spread across what were once parking lots and shopping malls. Within a few centuries, the city is barely recognizable, just mounds of rubble slowly being consumed by vegetation. Within a few thousand years, almost nothing remains. The organic materials, wood, paper, cloth, have long since decomposed. The metals have corroded away. Even the concrete and stone have been broken down by weathering and erosion. If you walked through the area, you might find a few anomalies, strange concentrations of certain minerals, oddly shaped stones, perhaps a fragment of glass or ceramic. But you would have to know what you were looking for, and you would have to dig deep. This is the challenge facing anyone who wants to find evidence of ancient civilizations. Time is a relentless eraser. The Earth reclaims everything we build, breaking it down and incorporating it back into the natural landscape. And the older something is, the less likely it is to survive. Most of what we know about ancient civilizations comes from stone. Pyramids, temples, monuments, and structures built to last. But stone buildings represent only a tiny fraction of what ancient peoples created. Most of their world was made of perishable materials: wood, thatch, mud brick, textiles, leather. These materials decay quickly, leaving little trace in the archaeological record. Consider the Indus Valley Civilization, which flourished in what is now Pakistan and northwestern India around 4,500 years ago. The cities of Harappa and Mohenjo-daro were sophisticated urban centres with advanced drainage systems, standardized weights and measures, and a writing system that we still haven't deciphered. But we know relatively little about the Indus Valley people because most of their buildings were made of mud brick which erodes easily. If not for the stone seals and pottery they left behind, we might not know they existed at all. Now imagine a civilization that existed not 4,500 years ago, but 12,000 or 15,000 years ago, before the end of the Ice Age. If they built primarily with wood and other organic materials, almost nothing would survive. If their cities were located on coastlines that are now underwater, we would have no easy way to find them. And if they were destroyed by a catastrophic event, a flood, an earthquake, a volcanic eruption, the evidence would be scattered and buried, difficult to distinguish from natural geological processes. This is why some researchers argue that the absence of evidence is not evidence of absence. Just because we haven't found clear proof of advanced prehistoric civilizations doesn't mean they didn't exist. It might simply mean we haven't looked in the right places, or that the evidence has been erased by time. But there are hints, anomalies that don't quite fit the standard narrative, objects and structures that seem out of place, too advanced for their supposed age, or too old for their level of sophistication. In Iraq, archaeologists discovered what appeared to be ancient batteries, clay jars containing copper cylinders and iron rods sealed with asphalt. When filled with an acidic liquid like vinegar, these Baghdad batteries can produce a small electric current. Mainstream archaeologists believe they were used for electroplating gold onto silver, but the fact that ancient peoples might have understood basic electrical principles is intriguing. In Egypt, the Dendera light reliefs in the Temple of Hathor show what some researchers interpret as ancient light bulbs, elongated objects that look remarkably like modern electric lamps, complete with what appears to be a filament and a power source. Mainstream Egyptologists explain these as symbolic representations of mythological concepts, but the resemblance to modern technology is striking. In Colombia, gold artifacts from the pre-Columbian era depict what look like airplanes or flying machines, streamlined objects with wings, tails, and what appear to be cockpits. When aeronautical engineers built scale models of these artifacts and tested them, they found that the designs were aerodynamically sound and could actually fly. Were these just stylized representations of birds or insects, or were they models of something the ancient peoples had actually seen? In India, ancient Sanskrit texts describe vimanas, flying machines used by the gods and heroes of Hindu mythology. The descriptions are detailed, including specifications for construction, fuel sources, and flight maneuvers. Some researchers have suggested that these texts might be garbled memories of actual flying machines from an earlier age, though mainstream scholars interpret them as purely mythological. These anomalies are controversial, and most archaeologists dismiss them as misinterpretations or coincidences. But they raise an interesting question. If an advanced civilization existed in the distant past and was destroyed, what would we expect to find? And how would we recognize it? The problem is that we're looking for evidence of a civilization that might have been very different from our own. We assume that advanced societies must leave behind the same kinds of artifacts we produce: metal tools, written records, monumental architecture. But what if an ancient civilization developed along different lines? What if they focused on organic technologies, sustainable practices, or knowledge systems that left little physical trace? Some researchers have suggested that ancient peoples might have possessed advanced understanding of acoustics, using sound and vibration for purposes we don't fully understand. The megalithic structures at sites like Stonehenge and Newgrange show evidence of acoustic engineering, with chambers designed to amplify and resonate certain frequencies. Were these just happy accidents, or did the builders understand principles of sound that we're only now rediscovering? Others point to evidence of advanced astronomical knowledge. The Antikythera mechanism, which we discussed earlier, demonstrates that ancient Greeks could track celestial movements with remarkable precision. But similar knowledge appears in cultures around the world. The Maya developed a calendar system so accurate that it rivals modern astronomical calculations. The builders of Stonehenge aligned the monument with the summer solstice. The ancient Egyptians oriented the pyramids to true north with extraordinary precision. This astronomical knowledge suggests that ancient peoples were carefully observing the sky, tracking patterns over long periods of time and passing that knowledge down through generations. But why? What motivated them to invest so much effort in understanding the movements of the stars? One possibility is that they were trying to predict catastrophes. Many ancient cultures believed that celestial events, eclipses, comets, planetary alignments, were omens of disaster. If they had experienced catastrophic events in the past, they might have been watching the sky for signs that another catastrophe was coming, trying to find patterns that would allow them to prepare or escape. This brings us back to the myths of cyclical destruction, the idea that the world has ended and begun again multiple times. In Hindu cosmology, time is divided into vast cycles called yugas. Each cycle lasts thousands or millions of years, and at the end of each cycle the world is destroyed and recreated. We are currently in the Kali Yuga, the age of darkness and decline, which will eventually end in destruction before the cycle begins again. The ancient Greeks had a similar concept, dividing history into ages: the Golden Age, the Silver Age, the Bronze Age, and the Iron Age. Each age was progressively worse than the one before, with humanity declining in virtue and wisdom. The Iron Age, the current age, would eventually end in catastrophe, after which the cycle would begin anew. The Maya believed in a series of world ages, each lasting approximately 5,025 years. At the end of each age, the world would be destroyed and recreated. The most recent age was supposed to end on December 21st, 2012, leading to widespread speculation about apocalyptic events. When nothing dramatic happened, many dismissed the Maya calendar as superstition. But the Maya themselves never predicted the end of the world, only the end of a cycle and the beginning of a new one. These cyclical cosmologies suggest that ancient people saw time not as a straight line, but as a wheel, turning and returning. And they believed that catastrophe was not an aberration, but a natural part of the cycle, something that had happened before and would happen again. But what could cause such catastrophes? What forces are powerful enough to destroy entire civilizations and reset human history? The Earth is not a stable place. We like to think of the ground beneath our feet as solid and unchanging, but the reality is that our planet is in constant motion, driven by forces that operate on timescales far longer than human lifetimes. The continents drift across the surface of the globe, colliding and separating in a slow dance that has been going on for billions of years. Volcanoes erupt, spewing ash and lava that can alter the climate for years. Earthquakes shake the ground, toppling cities and reshaping coastlines. And from time to time, objects from space, asteroids and comets, collide with the Earth, releasing energy equivalent to thousands of nuclear bombs. Any of these forces could be enough to destroy a civilization. And throughout human history, we have evidence that all of them have occurred, sometimes with devastating consequences. Let's start with volcanoes. Around 74,000 years ago, Mount Toba in Indonesia erupted in what is considered the largest volcanic eruption in the past 2 million years. The eruption ejected an estimated 2,800 cubic kilometers of material into the atmosphere, creating a volcanic winter that lasted for years. Temperatures around the world dropped by several degrees. Sunlight was blocked by ash and sulfur dioxide, causing widespread crop failures and famine. Some researchers believe the Toba eruption nearly wiped out humanity. Genetic studies suggest that the human population went through a severe bottleneck around this time, with the total number of breeding individuals dropping to perhaps as few as a few thousand. If there were human civilizations or complex societies before Toba, they would have been devastated by the eruption and the climate change that followed. The survivors would have been scattered, isolated, and forced to start over with limited resources and knowledge. But Toba is not the only supervolcano that has threatened humanity. Yellowstone, in the western United States, sits atop a massive volcanic hotspot that has erupted catastrophically 3 times in the past 2 million years. The most recent eruption occurred 640,000 years ago, but the volcano is still active, and geologists warn that another eruption is possible, though not imminent. If Yellowstone were to erupt today, it would blanket much of North America in ash, disrupt global climate patterns, and potentially cause a collapse of modern civilization. Then there are earthquakes. The Earth's crust is divided into tectonic plates that are constantly moving, grinding against each other at their boundaries. When the stress becomes too great, the plates suddenly shift, releasing energy in the form of seismic waves. The most powerful earthquakes can level entire cities, trigger tsunamis that inundate coastlines, and cause landslides that bury settlements. Around 1600 BCE, a massive earthquake struck the eastern Mediterranean, contributing to the collapse of the Minoan civilization on Crete. The earthquake was followed by a volcanic eruption on the island of Santorini, which sent tsunamis crashing into the Minoan coast and covered the region in ash. The Minoans never fully recovered, and within a few generations their civilization had faded into history. In 365 CE, a massive earthquake struck the eastern Mediterranean, raising the island of Crete by several meters and triggering a tsunami that devastated coastal cities from Egypt to Greece. The Roman historian Ammianus Marcellinus described ships being carried inland and left stranded on rooftops. Thousands of people died, and the event contributed to the decline of several major cities in the region. More recently, the 2004 Indian Ocean earthquake and tsunami killed over 230,000 people and displaced millions more. The earthquake, with a magnitude of 9.1, was one of the most powerful ever recorded. The tsunami it generated travelled across the Indian Ocean, striking coastlines in Indonesia, Thailand, India, and Sri Lanka. Entire communities were wiped out in minutes, and the disaster served as a stark reminder of the destructive power of natural forces. But perhaps the most catastrophic events in Earth's history have come from space. Around 66 million years ago, an asteroid roughly 10 kilometers in diameter struck the Yucatan Peninsula in Mexico, creating the Chicxulub crater and triggering a mass extinction event that wiped out the dinosaurs and most other life on Earth. The impact released energy equivalent to billions of nuclear bombs, causing massive wildfires, tsunamis, and a nuclear winter that lasted for years. When the dust settled, the world was a very different place. Humans did not exist 66 million years ago, but we have experienced our own cosmic close calls. Around 12,800 years ago, as we discussed earlier, some researchers believe a comet or asteroid broke apart in the atmosphere and rained debris across North America and Europe. The impacts would have caused massive wildfires, triggered climate change, and potentially contributed to the extinction of large Ice Age mammals like mammoths and saber-toothed cats. More recently, in 1908, an asteroid or comet exploded over Tunguska, Siberia, flattening 2,000 square kilometers of forest. If the object had struck a populated area, the death toll would have been catastrophic. And in 2013, a meteor exploded over Chelyabinsk, Russia, shattering windows and injuring over 1,500 people. The meteor was only about 20 meters in diameter, but it released energy equivalent to 30 Hiroshima bombs. These events remind us that the Earth is not isolated from the rest of the solar system. We orbit the Sun in a cosmic shooting gallery, surrounded by asteroids, comets, and other debris left over from the formation of the solar system. Most of these objects are small and burn up harmlessly in the atmosphere. But every few thousand years something larger gets through, and when it does, the consequences can be devastating. If a large asteroid or comet were to strike the Earth today, it could destroy entire cities, trigger tsunamis, and cause global climate change. Depending on the size and location of the impact, it could potentially collapse modern civilization, forcing survivors to rebuild from scratch. And if such an impact occurred in the distant past, before recorded history, it could have wiped out any civilizations that existed at the time, leaving little trace for us to find. But there's another type of catastrophe that some researchers believe could reset human civilization: a pole shift. The Earth's magnetic field is generated by the movement of molten iron in the planet's outer core. This field protects us from harmful solar radiation and cosmic rays, and it's what makes compasses point north. But the magnetic field is not stable. It fluctuates in strength, and every few 100,000 years, it reverses completely, with the north and south magnetic poles switching places. The last magnetic reversal occurred about 780,000 years ago, and some scientists believe we may be overdue for another one. In recent decades, the magnetic field has been weakening, and the North Magnetic Pole has been moving faster than usual, migrating from northern Canada towards Siberia. Some researchers interpret these changes as signs that a reversal may be approaching. A magnetic reversal would not be instantaneous. It would likely take thousands of years to complete, during which time the magnetic field would be weak and chaotic. During this period, the Earth would be more vulnerable to solar radiation, which could damage satellites, disrupt power grids, and increase cancer rates. Some researchers have suggested that magnetic reversals could be linked to mass extinctions, though the evidence for this is debated. But there's a more controversial idea. What if the magnetic poles are linked to the physical poles? What if a magnetic reversal could trigger a shift in the Earth's crust, causing the continents to suddenly move to new positions? This idea, known as crustal displacement or pole shift theory, was popularized by Charles Hapgood in the 1950s. Hapgood proposed that the Earth's crust could slide over the mantle like the skin of an orange, causing entire continents to shift to new latitudes. Mainstream geologists reject this idea, arguing that there's no mechanism that could cause such a shift and no evidence that it has ever occurred. But the theory has persisted in fringe circles, often linked to predictions of catastrophic Earth changes and the end of civilization. Whether or not pole shifts are real, the idea taps into a deep human fear that the world we know could suddenly and dramatically change, that the ground beneath our feet is not as stable as we believe, and this fear is not entirely unfounded. The Earth has experienced dramatic climate shifts in the past, periods when the temperature changed rapidly and ecosystems were transformed. One of the most dramatic examples is the Younger Dryas, a period of sudden cooling that occurred around 12,800 years ago, just as the Ice Age was ending. For reasons that are still debated, temperatures in the Northern Hemisphere plummeted, and Ice Age conditions returned for about 1,200 years. Glaciers advanced, sea levels dropped, and ecosystems that had been adapting to warmer conditions were suddenly thrust back into the cold. The Younger Dryas ended just as abruptly as it began, around 11,600 years ago, when temperatures shot up and the ice sheets rapidly melted. The cause of these sudden climate shifts is still uncertain. Some researchers point to changes in ocean currents, triggered by the influx of meltwater from collapsing ice sheets. Others suggest volcanic eruptions or cosmic impacts. But whatever the cause, the Younger Dryas demonstrates that the Earth's climate can change rapidly and dramatically, with potentially devastating consequences for any civilizations that exist at the time. If there were advanced societies during the Ice Age, the Younger Dryas and the subsequent rapid warming would have been catastrophic. Coastal settlements would have been flooded as sea levels rose. Agricultural systems would have been disrupted by changing climate patterns. Trade networks would have collapsed as populations were displaced and resources became scarce. And in the chaos, much of the knowledge and technology of these societies could have been lost. This brings us to a question that has haunted researchers for generations. If advanced civilizations existed before recorded history and were destroyed by catastrophes, could any of their knowledge have survived? In the deserts of Egypt, the Great Sphinx stands as one of the most enigmatic monuments of the ancient world. Carved from a single outcrop of limestone, the Sphinx depicts a creature with the body of a lion and the head of a human, gazing eternally toward the east. According to conventional Egyptology, the Sphinx was built around 4,500 years ago during the reign of Pharaoh Khafre as part of the Giza pyramid complex. But some researchers have questioned this dating. In the 1990s, geologist Robert Schoch examined the Sphinx and noticed something unusual: the pattern of erosion on the body of the monument. The deep vertical fissures and undulating surface suggested erosion by water, not wind and sand. Schoch argued that this type of erosion could only have been caused by prolonged exposure to heavy rainfall, which would place the construction of the Sphinx much earlier, perhaps as far back as 7,000 to 9,000 years ago, when the climate of Egypt was wetter. Mainstream Egyptologists have strongly disputed Schoch's conclusions, arguing that the erosion could be explained by other factors, such as wind, sand, and the weathering of different layers of limestone. But the debate has raised an intriguing possibility. What if the Sphinx is much older than we think? What if it was built by a civilization that predates ancient Egypt, and the Egyptians simply inherited and maintained it? This idea fits with Egyptian mythology, which speaks of the Zep-Tepi, the first time, a golden age when the gods ruled Egypt and taught humanity the arts of civilization. According to these myths, the knowledge of the gods was preserved in sacred texts and passed down through generations of priests. The pyramids and temples were said to be built according to this ancient knowledge, following plans that had been handed down from the first time. Could the Sphinx be a remnant of this earlier age? Could it be a monument built by a civilization that existed before the rise of dynastic Egypt, a marker left behind to preserve knowledge or commemorate something important? The idea of ancient knowledge being preserved through catastrophes appears in many traditions. In ancient Greece, Plato wrote that the Egyptian priest told Solon, the Athenian lawmaker, that the Greeks were like children because they had no memory of the distant past. The Egyptians, by contrast, claimed to have records going back thousands of years, preserved in their temples and passed down through their priesthood. In the biblical tradition, the Book of Enoch describes how angels taught humanity forbidden knowledge: astronomy, metallurgy, cosmetics, and sorcery. When God decided to destroy the world with a flood, this knowledge was nearly lost, but some of it was preserved by Noah and his descendants. In Hindu tradition, the Vedas are said to be eternal knowledge, revealed to ancient sages and passed down through oral tradition for thousands of years before being written down. The texts contain detailed information about astronomy, mathematics, medicine, and philosophy, suggesting a sophisticated understanding of the world. In South America, the Inca claimed that their civilization was founded by Manco Capac, who emerged from Lake Titicaca carrying knowledge given to him by the sun god Inti. The Inca built their empire according to this divine knowledge, creating a vast network of roads, agricultural terraces, and administrative centres that stretched across the Andes. These traditions share a common theme. Knowledge came from somewhere else, from an earlier time or a divine source, and was preserved through catastrophe. The implication is that civilization did not develop gradually from scratch, but was jump-started by wisdom inherited from the past. But how could knowledge be preserved through a catastrophe that destroyed cities, scattered populations, and disrupted societies? How could information survive when writing systems were lost, libraries were burned, and entire cultures were wiped out? One answer is oral tradition. Before the invention of writing, knowledge was preserved through stories, songs, and rituals passed down from generation to generation. Oral traditions can be remarkably stable, preserving information for thousands of years with surprising accuracy. Aboriginal Australians, for example, have oral traditions that describe geological events, such as the flooding of coastal areas and the formation of volcanic features that occurred over 10,000 years ago. When researchers compared these stories to geological evidence, they found that the oral traditions were accurate, preserving memories of real events across hundreds of generations. But oral tradition has limitations. It's vulnerable to distortion, as stories change with each retelling. It's vulnerable to loss, as knowledge can disappear if the people who carry it die without passing it on. And it's vulnerable to misinterpretation, as later generations may not understand the original meaning of the stories. Another way to preserve knowledge is through monuments and symbols. If you wanted to pass information to future generations, you could encode it in stone, creating structures that would survive long after your civilization had fallen. The pyramids, the megaliths, the temples, all of these could be seen as attempts to preserve knowledge in a form that would endure. Some researchers have suggested that the dimensions and alignments of ancient monuments encode mathematical and astronomical information. The Great Pyramid, for example, has been analysed for hidden meanings in its proportions. The ratio of the pyramid's height to its base perimeter is close to the ratio of a circle's radius to its circumference. In other words, pi. The pyramid's orientation to true north is remarkably precise, and some researchers claim that the layout of the Giza pyramids mirrors the constellation Orion, suggesting that the builders were encoding astronomical knowledge in stone. Whether or not these interpretations are correct, the idea that ancient monuments could serve as repositories of knowledge is intriguing. If a civilization knew that catastrophe was coming, they might try to preserve their most important knowledge in a form that would survive, not in books or digital files which are fragile and easily destroyed, but in massive stone structures that would endure for millennia. But there's another possibility, one that's more speculative and more controversial. What if knowledge was preserved by survivors who carried it to other parts of the world? If an advanced civilization was destroyed by a catastrophe, some people would have survived. They would have been scattered, displaced, and traumatized. But they would have carried with them memories of what had been lost. And if they settled in new lands and interacted with other cultures, they might have shared their knowledge, influencing the development of later civilizations. This idea that survivors of a lost civilization spread across the world and influenced other cultures appears in many myths and legends. The Egyptians spoke of the Shemsu-Hor, the followers of Horus, who were said to be survivors of an earlier age who brought knowledge to Egypt. The Sumerians told of the Apkallu, sages who emerged from the sea and taught humanity the arts of civilization. The Maya spoke of Kukulkan, a bearded god who came from across the sea and brought knowledge and culture. Could these myths be memories of real people, survivors of a lost civilization who travelled to new lands and shared their knowledge? Could the sudden appearance of advanced knowledge in ancient cultures, writing, mathematics, astronomy, architecture, be explained by contact with survivors who carried this knowledge from an earlier age? The idea is speculative, and there's no definitive proof, but it offers a possible explanation for some of the mysteries we've discussed. the sudden appearance of sophisticated structures like Gobekli Tepe, the advanced astronomical knowledge of ancient cultures, the global distribution of flood myths, and the legends of gods and sages who brought civilization to humanity. If such survivors existed, they would have been few in number, and their influence would have been limited. They couldn't rebuild their civilization from scratch. They lacked the population, the resources, and the infrastructure. But they could share what they knew, teaching the people they encountered and helping them develop their own civilizations. Over time, the memory of where this knowledge came from would fade, and the survivors would be remembered as gods, heroes, or mythical beings. This brings us to one of the most intriguing and controversial questions in the study of ancient history. Were there advanced civilizations before recorded history? And if so, what happened to them? The conventional narrative of human history goes something like this. For most of our existence as a species, humans lived as hunter-gatherers, moving from place to place in small bands, surviving by hunting animals and gathering plants. Around 12,000 years ago, we began to domesticate plants and animals, which allowed us to settle in one place and develop agriculture. Agriculture led to surplus food, which led to population growth, which led to the development of cities, writing, and complex societies. The first civilizations, Sumer, Egypt, the Indus Valley, emerged around 5,000 to 6,000 years ago, and from there, human history unfolds in a more or less continuous line to the present day. This narrative is based on solid archaeological evidence. We have artifacts, ruins, and written records that document the rise of these early civilizations. We can trace the development of agriculture, the invention of writing, and the growth of cities. The story makes sense, and it fits with what we know about human development. But the narrative has gaps. There are periods of time, especially before the invention of writing, where our knowledge is limited. There are regions of the world that have not been thoroughly explored by archaeologists, and there are anomalies, structures, artifacts, and myths that don't quite fit the standard story. What if the narrative is incomplete? What if there were civilizations that rose and fell before the ones we know about? Civilizations that left few traces because they were destroyed by catastrophes, or because their remains are now underwater or buried beneath layers of sediment? This is the central question of what some researchers call alternative archaeology, or forbidden archaeology, the idea that human history is older and more complex than mainstream scholars acknowledge. Proponents of this view point to the anomalies we've discussed, the advanced engineering of ancient monuments, the sudden appearance of sophisticated knowledge, the global distribution of flood myths, and the legends of lost civilizations like Atlantis. Critics argue that alternative archaeology is based on speculation, misinterpretation, and a misunderstanding of how archaeology works. They point out that extraordinary claims require extraordinary evidence, and that the evidence for advanced prehistoric civilizations is lacking. The anomalies, they say, can be explained by conventional means. Ancient peoples were more capable than we give them credit for. Myths are not reliable historical sources, and the absence of evidence for lost civilizations is significant. The debate is contentious, and it often generates more heat than light. But it raises important questions about how we understand the past and what we're willing to consider possible. One of the challenges in this debate is defining what we mean by advanced. When we think of advanced civilizations, we tend to think of technology, machines, computers, electricity, and so on. But advancement can take many forms. A society could be advanced in terms of social organization, art, philosophy, or spiritual understanding without necessarily developing the same technologies we have. Consider the ancient Greeks. They made remarkable advances in philosophy, mathematics, and science, laying the foundations for Western thought. But they never developed industrial technology. They had the knowledge to build steam engines. Hero of Alexandria created a simple steam-powered device in the 1st century CE. but they never scaled it up or used it for practical purposes. Why? Perhaps because they had abundant slave labour and saw no need for labour-saving machines. Or perhaps because their culture valued other things more than technological innovation. Similarly, a prehistoric civilization could have been advanced in ways that left a little physical trace. They might have developed sophisticated understanding of agriculture, ecology, and sustainable living. They might have had complex social structures, rich artistic traditions, and deep philosophical or spiritual insights. They might have built with organic materials that have since decayed, leaving no ruins for us to find. This is one reason why the search for lost civilizations is so difficult. We're looking for evidence of something that might have been very different from what we expect. And we're looking in a world where time has erased most of the traces. But there are places where the search continues, places where researchers believe they might find evidence of lost civilizations. One of these places is the ocean floor. As we discussed earlier, sea levels were much lower during the Ice Age, exposing vast coastal plains that are now underwater. If humans were living in these areas, and it seems likely they were, given that coastlines offer abundant resources, then their settlements would now be submerged. Underwater archaeology is a relatively new field, and much of the ocean floor remains unexplored. But as technology improves, researchers are beginning to map and investigate underwater sites that might hold clues to our distant past. Another place to look is beneath the ice. Antarctica, for example, is covered by ice sheets that are thousands of feet thick in places. But it wasn't always this way. Millions of years ago, Antarctica was much warmer and supported forests and diverse ecosystems. Could there be evidence of ancient life, or even ancient civilizations, buried beneath the ice? Some researchers have suggested that if a global civilization existed before the Ice Age, remnants of it might be preserved in Antarctica, frozen in time. The idea is highly speculative, but it's not impossible. A third place to look is in regions that have not been thoroughly explored by archaeologists. The Amazon rainforest, for example, was long thought to be a pristine wilderness, largely untouched by human activity. But recent research using LiDAR technology, which uses laser pulses to map the ground beneath vegetation, has revealed extensive networks of ancient settlements, roads, and earthworks hidden beneath the jungle canopy. These discoveries suggest that the Amazon was home to large, complex societies before European contact, societies that were largely wiped out by disease and colonization. If the Amazon held hidden civilizations, what other regions might contain undiscovered ruins? The Sahara Desert, which was once a lush, green landscape with rivers and lakes, could hold evidence of ancient settlements now buried beneath the sand. The steppes of Central Asia, the highlands of Tibet, the remote islands of the Pacific, all of these regions remain largely unexplored, and any of them could hold surprises. But even if we find evidence of previously unknown civilizations, it might not answer the deeper question, have we started over? Have there been cycles of rise and fall, of civilization and collapse, stretching back into the distant past? To answer that question, we need to think about what it would take for a civilization to truly reset, to fall so completely that later generations have no memory of it, no knowledge of what came before. Imagine a catastrophe, not a local disaster, but a global event that affects every part of the world simultaneously. Perhaps it's a massive asteroid impact like the one that killed the dinosaurs. Perhaps it's a supervolcano eruption like Toba that plunges the world into volcanic winter. Perhaps it's a rapid climate shift like the Younger Dryas that disrupts ecosystems and makes survival difficult. Or perhaps it's a combination of factors, a perfect storm of disasters that strikes at the worst possible time. In the immediate aftermath, the death toll would be staggering. Cities would be destroyed, infrastructure would collapse, and supply chains would break down. Without electricity, clean water, or food distribution systems, modern civilization would grind to a halt within days. Survivors would be scattered, isolated and focused entirely on immediate survival, finding food, water, and shelter. Within a generation, much of our technological knowledge would be lost. The people who know how to build computers, generate electricity, or manufacture medicines would be gone, and their knowledge would die with them. Books and digital records would decay or become inaccessible. The survivors would be forced to rely on basic skills, hunting, gathering, farming, just to stay alive. Within a few generations, the memory of the old world would fade. Children born after the catastrophe would grow up in a world very different from the one their grandparents knew. They would hear stories about the time before, but these stories would become increasingly distorted, taking on mythical qualities. The skyscrapers and highways would be remembered as the works of giants or gods. The technology would be remembered as magic. Within a few thousand years, almost all physical evidence of the old civilization would be gone. The buildings would have collapsed. The roads would have been reclaimed by nature, and the artifacts would have corroded or decomposed. If a new civilization arose, its people might find strange objects in the ground. Fragments of metal, pieces of glass, oddly shaped stones, but they would have no context for understanding what these objects were or what they meant. This is how a civilization resets, not through a single dramatic event, but through a process of collapse, loss, and forgetting that unfolds over generations. And if it has happened once, it could happen again. It could have happened many times. But here's the unsettling part. If civilizations have risen and fallen multiple times in the past, we might not be able to tell. The evidence would be scattered, fragmentary, and difficult to interpret. We might find anomalies, objects or structures that seem out of place, but we wouldn't have enough context to understand them. We might have myths and legends that preserve memories of earlier ages, but we wouldn't be able to separate fact from fiction. In other words, we might be living in a world where humanity has already started over multiple times, and we simply don't know it. This idea is both humbling and terrifying. Humbling because it suggests that we're not as unique or as advanced as we like to think. Terrifying because it suggests that everything we've built, our cities, our technology, our knowledge, could be swept away, just as it may have been swept away before. But there's another way to look at it. If humanity has survived multiple resets, it means we're resilient. It means we have the capacity to rebuild, to adapt, to start over and create something new. It means that even in the face of catastrophe, we endure. And perhaps that's the real lesson of the myths and legends we've explored. The flood stories, the tales of lost civilizations, the legends of gods and heroes who brought knowledge to humanity. All of these stories are ultimately about survival and renewal. They're about the end of one world and the beginning of another. They're about the cycle of destruction and creation that seems to be woven into the fabric of existence. The Hopi speak of multiple worlds, each destroyed when humanity fell out of balance. The Hindus speak of yugas, vast cycles of time that end in dissolution and rebirth. The Maya speak of world ages, each lasting thousands of years before giving way to the next. These cosmologies don't see history as a straight line, but as a spiral, turning and returning, rising and falling in patterns that repeat across the ages. And maybe they're right. Maybe time is not linear but cyclical. Maybe the story of humanity is not a story of steady progress, but a story of rise and fall, of building and losing, of remembering and forgetting. If that's true, then the question is not whether we've started over before, but whether we're approaching another turning point. Are we nearing the end of another cycle? Are we building toward another collapse? There are signs that give some people pause. The climate is changing, and changing rapidly. Global temperatures are rising, ice sheets are melting, and sea levels are creeping upward. Extreme weather events, hurricanes, droughts, floods, wildfires, are becoming more frequent and more severe. Ecosystems are collapsing, species are going extinct at rates not seen since the age of the dinosaurs. At the same time, our civilization has become incredibly complex and interconnected. We depend on global supply chains, electrical grids, and communication networks that are vulnerable to disruption. A major solar storm could knock out satellites and power grids, plunging much of the world into darkness. A pandemic, as we've recently experienced, can spread across the globe in a matter of weeks, overwhelming healthcare systems and disrupting economies. A cyber attack could cripple financial systems, transportation networks, or critical infrastructure. We've built a civilization that is powerful and sophisticated, but also fragile. We've created systems that work beautifully when everything is functioning normally, but that can fail catastrophically when something goes wrong. And we've done this while depleting resources, degrading ecosystems, and altering the climate in ways that could have long-term consequences we don't fully understand. Some researchers warn that we're approaching a tipping point, a moment when the stresses on our civilization become too great, and the whole system begins to unravel. They point to historical examples, the collapse of the Roman Empire, the fall of the Maya, the Bronze Age collapse, as warnings of what can happen when civilizations become too complex, too rigid, or too disconnected from the natural systems that support them. Others are more optimistic. They argue that human ingenuity and adaptability will allow us to solve the problems we face. They point to technological advances, renewable energy, artificial intelligence, space exploration, as evidence that we're capable of overcoming challenges and continuing to progress. But whether we're optimistic or pessimistic, the question remains, if we were to face a catastrophic collapse, what would survive? What knowledge would we preserve? What would we pass on to future generations? This is not an idle question. Throughout history, people have tried to preserve knowledge for the future, creating time capsules, archives, and monuments designed to outlast their creators. The ancient Egyptians built pyramids that have stood for thousands of years. Medieval monks copied manuscripts by hand, preserving classical knowledge through the Dark Ages. Modern societies have created seed banks, digital archives, and even plans to store information on the moon, just in case something happens to Earth. But preserving knowledge is harder than it seems. Physical media decay, paper crumbles, stone erodes, digital files become unreadable as technology changes. Languages evolve and die, making old texts incomprehensible. And even if the information survives, there's no guarantee that future generations will be able to find it, understand it, or use it. This is why some researchers have proposed creating a Rosetta Stone for the future, a message encoded in multiple languages and formats, designed to be understandable even if our civilization collapses. The message would contain basic information about who we are, what we know, and what we've learned. It would be a gift to whoever comes after, a way of saying, we were here, we learned these things, and we hope you can build on what we've discovered. But what would such a message say? What knowledge is most important to preserve? The laws of physics? The principles of agriculture? The lessons of history? The wisdom of philosophy? Perhaps the most important message would be the simplest. You are not alone. Others have walked this path before. Civilizations have risen and fallen, and each time humanity has endured. The cycle continues, and you are part of it. As we near the end of this journey through time and myth, through archaeology and speculation, it's worth stepping back and considering what we've explored. We've looked at evidence of lost cities beneath the oceans, of underground refuges carved into solid rock, of monuments that seem too advanced for their time. We've examined myths and legends from around the world that speak of catastrophic floods, of worlds that ended and began again, of knowledge passed down from earlier ages. We've considered the forces that could destroy civilizations: volcanoes, earthquakes, asteroids, climate change, and we've asked whether such catastrophes have happened before and could happen again. We've explored the idea that human history might be older and more complex than we've been taught, that there might have been civilizations before the ones we know about, civilizations that rose and fell and left only fragments behind. And we've considered the possibility that we are not the first to reach for the stars, not the first to build great monuments, not the first to believe we had conquered nature itself. But we've also acknowledged the limitations of this exploration. We don't have definitive proof of advanced prehistoric civilizations. The evidence is fragmentary, ambiguous, and open to interpretation. The mainstream scientific consensus is that human civilization developed gradually over the past 10,000 years, and that there's no credible evidence for advanced societies before that time. So where does that leave us? Are we chasing shadows, seeing patterns where none exist, projecting our own fears and hopes onto the distant past? Or are we asking important questions, challenging assumptions, and opening ourselves to possibilities that mainstream scholarship has overlooked? Perhaps the answer is both. Perhaps the value of exploring these ideas is not in finding definitive answers, but in asking the questions themselves. In wondering about our place in time, about the fragility of what we've built, about the cycles of rise and fall that seem to echo through history. Because even if there were no advanced civilizations before recorded history, even if the myths are just stories and the anomalies have conventional explanations, the questions remain relevant. We live in a time of extraordinary achievement and extraordinary vulnerability. We live on the edge of capabilities that would have seemed like magic to our ancestors just a few generations ago. And yet we also live on the edge of catastrophes that could unravel everything we've built. We live in a moment where we can see both backward into deep time and forward into possible futures, and what we see in both directions should give us pause. The question is not really whether lost civilizations existed before ours. The question is what we can learn from the possibility that they did. What does it mean to build a civilization knowing that civilizations can fall? What does it mean to accumulate knowledge knowing that knowledge can be lost? What does it mean to reach for permanence in a world where nothing is permanent? These are not abstract philosophical questions. They're practical ones, urgent ones, questions that should shape how we think about the world we're building right now. Let's start with a simple observation. Our civilization is more advanced than any that came before it, at least in terms of technology and the sheer scale of our impact on the planet. We've split the atom, mapped the human genome, sent machines to other planets, connected billions of people through invisible networks of information. We've built cities that house tens of millions, created systems that move goods and people across continents in hours, developed medicines that have doubled human lifespans. By any measure, we've achieved things that would have been incomprehensible to people living just a few centuries ago. But here's the uncomfortable truth. Our civilization is also more fragile than we like to admit. Not despite our advancement, but in some ways because of it. We've built a world of extraordinary complexity and interdependence, a world where everything connects to everything else, where a disruption in one place can cascade through the entire system. Consider the global supply chain. Right now, as you read this, millions of containers are moving across oceans, carrying everything from food to electronics to medical supplies. This system is so efficient, so finely tuned, that most stores keep only a few days' worth of inventory. We've optimized for efficiency, not resilience. We've eliminated redundancy because redundancy is expensive. But what happens when that system breaks down? We got a glimpse during the COVID-19 pandemic, when a single virus brought global trade to a near standstill. Suddenly, there were shortages of everything from toilet paper to semiconductors. Hospitals ran out of basic protective equipment. The just-in-time supply chain that had seemed so elegant revealed itself to be a house of cards. And that was a relatively mild disruption, one that we saw coming and had months to prepare for. Imagine a more sudden shock, a major cyber attack on shipping networks, a conflict that closes key trade routes, a series of natural disasters that hit multiple manufacturing hubs simultaneously. How quickly would our shelves empty? How long would it take for order to break down? The same fragility exists in our food systems. Most people in developed countries are completely dependent on a complex network of industrial agriculture, processing plants, and distribution systems. Very few of us know how to grow our own food, preserve it, or survive without the grocery store. We're 3 meals away from chaos, as the saying goes, and it's not much of an exaggeration. Our electrical grids are another single point of failure. Modern life depends entirely on electricity, not just for lights and entertainment, but for water pumps, sewage systems, refrigeration, communication, transportation, medical equipment. Yet our grids are aging, vulnerable to both natural disasters and deliberate attacks. A major solar storm like the Carrington event of 1859 could knock out power across entire continents for months or even years. In 1859, when our technology was primitive, the storm just caused some telegraph wires to spark. Today, it could be catastrophic. And then there's the internet, the nervous system of modern civilization. We've moved so much of our infrastructure online: banking, commerce, government services, communication, entertainment, education. But the internet was never designed with security as a priority. It's vulnerable to attacks, to cascading failures, to simple accidents. What happens when it goes down for more than a few hours? How much of our civilization simply stops functioning? These are not hypothetical concerns. They're vulnerabilities that experts have been warning about for years. We've built a civilization that's incredibly powerful but also incredibly brittle. A civilization that works beautifully under normal conditions but could shatter under stress. In some ways, this makes us very different from past civilizations. The ancient Romans didn't depend on electricity or global supply chains. If one city fell, others could continue. If one region experienced famine, other regions might still have food. There was redundancy built into the system, not by design but by necessity. Communication was slow, travel was difficult, and each community had to be relatively self-sufficient. But in other ways, we're remarkably similar to civilizations that came before us. We're making the same assumptions, falling into the same traps, displaying the same blind spots that have led to collapse throughout history. One of those assumptions is that growth can continue indefinitely. Every civilization that has risen to prominence has believed that its expansion would never end, that there would always be new lands to conquer, new resources to exploit, new frontiers to push into. The Romans believed it, the Maya believed it, the British Empire believed it, and we believe it too, even though we live on a finite planet with finite resources. We're consuming resources faster than they can be renewed. We're changing the climate in ways that could make large parts of the planet uninhabitable. We're driving species to extinction at rates not seen since the asteroid that killed the dinosaurs. And yet we continue to organize our economies around the assumption of perpetual growth, as if the laws of physics and ecology don't apply to us. Another assumption is that complexity equals stability. We tend to think that more advanced systems are more robust, that redundancy and backup systems make us safer. But complexity can also be a source of fragility. The more interconnected a system becomes, the more ways there are for it to fail. The more specialized we become, the more dependent we are on the smooth functioning of the entire system. The ancient world had its own forms of complexity: trade networks, administrative bureaucracies, military logistics. And when those systems broke down, civilizations collapsed. The Bronze Age collapse wasn't caused by a single catastrophe, but by a cascade of failures: drought, famine, invasions, the breakdown of trade routes. Once the system started to unravel, it couldn't be stopped. We're not so different. Our systems are more sophisticated, but they're also more tightly coupled. A failure in one area can propagate through the entire network faster than we can respond. We've seen this in financial markets, where automated trading algorithms can trigger crashes in milliseconds. We've seen it in power grids, where a single failure can cascade into blackouts affecting millions. We've seen it in social media, where misinformation can spread faster than truth. And perhaps most troubling, we display the same psychological blind spots that have afflicted every civilization that came before us. We suffer from what psychologists call normalcy bias. the tendency to believe that things will continue as they always have, that the future will resemble the past. We have trouble imagining catastrophic change, even when the warning signs are all around us. This is why people build houses in flood zones, why they ignore evacuation orders, why they assume that the systems they depend on will always be there. It's not stupidity or ignorance. It's a fundamental feature of human psychology. We're wired to focus on immediate threats, not long-term risks. We're wired to trust in the stability of our environment, because for most of human history, that was a useful adaptation. But in a world of rapid change and systemic risks, normalcy bias can be deadly. It's what allows us to see the ice caps melting, the forests burning, the species disappearing, and still assume that everything will somehow work out. It's what allows us to build nuclear weapons capable of destroying civilization and then trust that they'll never be used. It's what allows us to create artificial intelligence without fully understanding the risks, to edit genes without knowing all the consequences, to alter the planet's chemistry and assume we can control the results. Every civilization that has collapsed probably felt the same way in its final years. The Romans in the 5th century, watching barbarians at the gates, probably couldn't imagine that Rome itself would fall. The Maya at the height of their power probably couldn't imagine their cities being abandoned to the jungle. The people of Easter Island, cutting down the last trees, probably couldn't imagine that their entire society would collapse. And yet it did. It always does, eventually. So what would survive us if our civilization collapsed tomorrow? What would future archaeologists find if they dug through the ruins of our cities 1,000 years from now? The answer is both more and less than you might think. Some things would last. Stone and concrete structures would endure for centuries, though they'd be weathered and overgrown. The pyramids have lasted thousands of years, and some of our largest buildings might do the same. Mount Rushmore could be recognizable for tens of thousands of years. The faces of presidents carved into granite, outlasting the nation they represented. Metal objects would survive for a while, though most would rust and corrode. Stainless steel might last longer, and some alloys could remain recognizable for thousands of years. Gold and platinum would endure almost indefinitely. So future archaeologists might find jewellery, coins, and certain industrial components, though they'd be scattered and corroded. Glass is surprisingly durable. Bottles and windows would break, but glass fragments could last for millions of years. Ceramics, too. Pottery shards are among the most common archaeological finds, and our dishes and tiles would join that record. Plastics are a wild card. We've created materials that nature has no way to break down efficiently. Some plastics might last for thousands or even millions of years, though they'd fragment into smaller and smaller pieces. Future geologists might find a layer of microplastics in the rock record, a signature of our age as distinctive as the iridium layer that marks the asteroid impact that killed the dinosaurs. But here's what wouldn't survive. Almost everything that makes our civilization what it is. Books would decay within decades, unless they were preserved in very dry conditions. Paper is organic, and organic materials rot. The vast libraries we've built, the millions of books we've written, would turn to dust. A few might survive in desert caves or frozen tundra, but the overwhelming majority would be gone within a century. Digital information would vanish even faster. Hard drives fail. Servers need power. The cloud is just someone else's computer, and those computers need constant maintenance. Without electricity and without people to maintain the systems, all of our digital data would be gone within years, maybe months. Think about what that means. We've moved so much of our knowledge into digital form. Scientific papers, technical manuals, historical records, photographs, videos, music, art. Billions of documents that exist only as patterns of magnetic fields or electrical charges. If the power goes out and stays out, all of that disappears. It's not just lost, it's gone, as if it never existed. Even if some storage devices survived physically intact, They'd be useless without the right hardware and software to read them. Imagine finding a hard drive from our era 1,000 years from now. It's a black box with no obvious way to access the information inside. You'd need a computer, an operating system, the right drivers, possibly passwords and encryption keys. Without all of that, it's just an inert lump of metal and plastic. This is the paradox of our information age. We've created more knowledge than any civilization in history, but we've stored it in the most fragile and ephemeral forms imaginable. We've traded durability for convenience, permanence for accessibility. The ancient Sumerians wrote on clay tablets that have survived for 5,000 years. We write on media that might not survive 5 years. And it's not just the storage media that's fragile, it's the knowledge itself. We've become so specialized that very few people understand how our technology actually works. Could you build a computer from scratch? Could you refine metal from ore, generate electricity, synthesize medicine, or even make paper? Most of us couldn't. We're dependent on vast networks of specialized knowledge, and if those networks break down, the knowledge disappears. This is very different from traditional societies, where essential knowledge was widely distributed. Everyone knew how to grow food, build shelter, make tools, treat common illnesses. Knowledge was passed down through apprenticeship and practice, embedded in the daily life of the community. It was resilient because it was redundant. Our knowledge is powerful but brittle. It's concentrated in the minds of specialists and encoded in systems that require constant maintenance. If those specialists disappear and those systems fail, we'd be left with almost nothing. Within a few generations, survivors of a collapse might not even believe that our civilization had existed. The stories would sound like myths, like the tales of Atlantis sound to us. But here's the crucial question. Are we doing anything differently? Are we learning from the patterns of the past, or are we repeating them? Are we building a civilization that can endure, or are we racing toward our own collapse? The honest answer is mixed. On one hand, we're aware of the risks in ways that past civilizations weren't. We study history, we model complex systems, we try to anticipate problems before they become catastrophic. We have institutions dedicated to monitoring threats, climate change, pandemics, asteroid impacts, nuclear proliferation. We have scientists working on solutions, engineers building resilience into our systems, policymakers trying to coordinate global responses. We've created seed banks to preserve genetic diversity in case of agricultural collapse. The Svalbard Global Seed Vault in Norway holds nearly 1 million seed samples, buried deep in permafrost, designed to survive even a nuclear war. It's a modern version of Noah's Ark, a hedge against catastrophe. We've sent information into space, hoping it might outlast us. The Voyager spacecraft carry golden records with sounds and images from Earth, messages to any alien civilization that might find them billions of years from now. We've proposed building archives on the Moon, where there's no atmosphere to corrode materials and no geological activity to bury them. We've created the Long Now Foundation, which is building a clock designed to run for 10,000 years, a monument to long-term thinking. We've encoded data in synthetic DNA, which can store information at incredible density and remain stable for thousands of years. We've etched knowledge onto metal plates, carved it into stone, tried to create formats that could survive the collapse of our technological civilization. These are all admirable efforts, signs that at least some people are thinking about the long term, about legacy and survival, and the possibility that our civilization might not last forever. But are they enough? Are we really changing our behavior, or are we just creating insurance policies while continuing to take the same risks? The uncomfortable truth is that we're not doing nearly enough. We're aware of the threats, but we're not acting on that awareness with the urgency the situation demands. We're like someone who knows they should quit smoking but keeps putting it off, who knows they should save for retirement but spends everything they earn, who knows the bridge is out ahead but keeps driving at full speed. Take climate change. We've known about the greenhouse effect for over a century. We've had clear evidence of human-caused warming for decades. We've seen the ice melting, the seas rising, the weather becoming more extreme. We've had countless reports from scientists warning that we're approaching tipping points beyond which the changes become irreversible. And yet we're still burning fossil fuels at record rates. We're still cutting down forests, still expanding into wild areas, still organising our economies around consumption and growth. We have the technology to transition to renewable energy, but we're not deploying it fast enough. We have the knowledge to live more sustainably, but we're not implementing it at scale. Why? Because the costs are immediate and the benefits are long-term. Because powerful interests profit from the status quo. Because it's easier to hope that someone else will solve the problem, that technology will save us, that it won't be as bad as the scientists say. Because we're human, and humans are really bad at responding to slow-moving threats. The same pattern plays out with other existential risks. We've built enough nuclear weapons to destroy civilization many times over, and we've come terrifyingly close to using them. During the Cuban Missile Crisis, we were one decision away from nuclear war. In 1983, a Soviet early warning system falsely detected incoming missiles, and only the judgment of one officer prevented a retaliatory strike. We've been lucky, but luck runs out. We're developing artificial intelligence without fully understanding how to control it or align it with human values. We're creating systems that could become more intelligent than us, and we're doing it in a competitive race where safety takes a backseat to capability. Some of the smartest people in the field are warning that this could be an existential threat, but the development continues at an accelerating pace. We're editing genes, creating synthetic organisms, experimenting with technologies that could fundamentally alter life on Earth. We're doing it with good intentions, to cure diseases, to feed the hungry, to solve problems, but we're also doing it without fully understanding the consequences. We're changing the code of life itself, and we're doing it faster than we can assess the risks. We're more connected than ever before, which means that pandemics can spread faster than ever before. COVID-19 circled the globe in weeks, and it was relatively mild compared to what's possible. A more lethal pathogen, whether natural or engineered, could kill hundreds of millions before we could develop a response. And yet, we're cutting funding for pandemic preparedness, closing monitoring stations, ignoring the warnings of epidemiologists. We're building systems that are increasingly vulnerable to cyber attacks, to cascading failures, to simple accidents. We're creating single points of failure and then trusting that they'll never fail. We're optimizing for efficiency and convenience, not for resilience and redundancy. In other words, we're doing exactly what civilizations have always done. We're prioritizing short-term gains over long-term survival. We're assuming that the future will take care of itself. We're trusting in our own cleverness and ignoring the lessons of history. But maybe awareness itself changes something. Maybe the fact that we're having this conversation, that we're thinking about cycles and collapse and the fragility of civilization, means that we have a chance to do things differently. This is the argument of the optimists, and it's not without merit. We are the first civilization to have a truly global perspective, to be able to see the whole planet as a single system. We're the first to have detailed records of past collapses, to be able to study what went wrong and why. We're the first to have the scientific tools to model complex systems, to anticipate problems, to coordinate responses across borders and cultures. We're also the first civilization to have the technological capability to actually do something about existential threats. We can detect asteroids and potentially deflect them. We can monitor the climate and model future changes. We can develop vaccines in months instead of years. We can communicate instantly across the globe, sharing information and coordinating action. And perhaps most importantly, we're the first civilization to have a significant number of people who are actively thinking about long-term survival, who are working to build resilience, who are trying to break the cycle of rise and fall. There are movements towards sustainability, toward renewable energy, towards circular economies that don't depend on endless extraction and consumption. There are people working on decentralized systems that don't have single points of failure. on local food production that doesn't depend on global supply chains, on technologies that are appropriate and maintainable rather than complex and fragile. There are communities experimenting with different ways of living, with different values and priorities. There are indigenous peoples who have maintained sustainable relationships with their environments for thousands of years, and there's growing recognition that we should learn from their wisdom rather than dismissing it. There are young people who are demanding change, who are refusing to accept the assumption that growth must continue forever, who are asking hard questions about what kind of world we're building and who it's for. All of this gives reason for hope. Maybe we can be the civilization that breaks the cycle. Maybe we can be the ones who learn from the past and build something that lasts. Maybe consciousness of the pattern is enough to change it. But hope is not a strategy. Awareness is not the same as action. And the clock is ticking. The psychology of civilizations is a strange thing. We're capable of remarkable foresight and planning. We build cathedrals that take centuries to complete. We plant trees we'll never see mature. We invest in education and infrastructure for future generations. But we're also capable of remarkable short-sightedness, of ignoring obvious threats, of prioritizing immediate comfort over long-term survival. Part of this is just human nature. Our brains evolved to deal with immediate concrete threats, predators, rivals, hunger, cold. We're good at responding to things we can see and touch, things that are happening right now. We're much worse at responding to abstract long-term threats, things that unfold over decades or centuries. This is why it's easier to get people to care about a single child trapped in a well than about millions of children dying from preventable diseases. The child in the well is immediate, visible, concrete. The millions are statistics, abstractions, too large to grasp emotionally. Climate change is the perfect example of a threat that our psychology is poorly equipped to handle. It's gradual, it's global, it's complex, and the worst effects are still in the future. It doesn't trigger our fight or flight response. It doesn't feel urgent, even though it is. The same is true for most existential risks. Nuclear war is a possibility, not a certainty. AI alignment is a technical problem, not a visible threat. Pandemic preparedness is about preventing something that hasn't happened yet. These threats don't activate our threat detection systems the way a charging lion would. But there's more to it than just individual psychology. There's also the psychology of groups, of institutions, of civilizations as a whole. Civilizations develop their own blind spots, their own assumptions and beliefs that become so deeply embedded that they're invisible. These beliefs shape what questions we ask, what solutions we consider, what futures we can imagine. For most of human history, the dominant belief was that the world was unchanging, that the future would be like the past, that the gods or fate or the natural order determined everything. This belief made people fatalistic, but it also made them cautious. They didn't try to reshape the world because they didn't think it was possible. Our civilization has the opposite belief, that change is not only possible but inevitable, that progress is the natural direction of history, that human ingenuity can solve any problem. This belief has driven remarkable achievements, but it's also made us reckless. We assume that technology will save us, that we can always innovate our way out of trouble, that there are no limits to what we can do. Both beliefs are wrong, or at least incomplete. The world does change, but not always in the direction we want. Progress is possible, but not inevitable. Technology can solve problems, but it can also create new ones. There are limits, and ignoring them doesn't make them go away. Another blind spot is the assumption that our civilization is fundamentally different from all the ones that came before, that we've transcended the patterns of history. We look at past collapses and think, that couldn't happen to us. We're too advanced, too knowledgeable, too connected. We see ourselves as the culmination of history, the endpoint of a long process of development. But every civilization has thought this. The Romans believed they had built an eternal empire. The Maya believed their cities would stand forever. The British believed the sun would never set on their empire. They were all wrong. We're not special. We're not exempt from the forces that have shaped history. We're subject to the same physical laws, the same ecological limits, the same human nature. Our technology is more advanced, but that doesn't make us immune to collapse. In some ways, it makes us more vulnerable. There's also a collective action problem that makes it hard for civilizations to respond to long-term threats. Even if everyone agrees that something needs to be done, it's hard to coordinate action when the costs are immediate and the benefits are distant. It's hard to get people to sacrifice now for a future they might not live to see. This is especially true in democratic societies, where leaders are elected for short terms and judged on immediate results. A politician who proposes painful but necessary changes is likely to lose to one who promises easy solutions and continued prosperity. So we get leaders who tell us what we want to hear, who kick the can down the road, who prioritize the next election over the next generation. But it's not just politicians, it's all of us. We want cheap energy, abundant food, convenient transportation, comfortable lives. We want these things now, and we don't want to pay the true costs. We externalize those costs onto future generations, onto other countries, onto other species, onto the planet itself. And we tell ourselves that it's fine, that someone will figure it out, that it's not our responsibility. This is how civilizations collapse. Not through a single catastrophic decision, but through 1,000 small choices, each one rational in the moment, each one pushing the problem a little further into the future, until suddenly the future arrives and the bill comes due. So let's talk about the specific threats we face, the ways our civilization could collapse, the catastrophes that could force humanity to start over. Climate change is the most obvious and most discussed. We're changing the composition of the atmosphere faster than at any time in millions of years. We're warming the planet, melting the ice, raising the seas, acidifying the oceans, disrupting weather patterns. The effects are already visible. More intense hurricanes, longer droughts, bigger wildfires, crop failures, mass migrations, and we're still in the early stages. If we continue on our current path, we're looking at a world that's 3, 4, maybe 5 degrees Celsius warmer by the end of this century. That might not sound like much, but it's enough to transform the planet. Large parts of the tropics could become too hot for human habitation. Agricultural zones would shift, and many areas would become unsuitable for farming. Sea level rise would inundate coastal cities where billions of people live. Extreme weather would become the norm. The result would be mass migration, resource conflicts, economic collapse, political instability. It wouldn't be the end of humanity, but it could be the end of our current civilization. It could force us to start over, to rebuild from a much lower level of complexity and capability. And that's assuming we don't hit tipping points that make the changes irreversible and self-reinforcing. If the permafrost melts and releases its stored methane, if the Amazon rainforest dies and turns into savanna, if the ocean currents shift, these are changes that could cascade beyond our ability to control them. Nuclear war is another existential threat, one that we've lived with for over 70 years. We've been lucky so far, but luck doesn't last forever. There are still thousands of nuclear weapons in the world, many of them on hair-trigger alert, ready to launch within minutes. The systems that control them are aging, the people who operate them are human and fallible, and the political tensions that could lead to their use haven't gone away. A full-scale nuclear exchange between major powers would kill hundreds of millions of people directly. But the real catastrophe would come from the nuclear winter that followed. The fires from burning cities would inject massive amounts of smoke into the stratosphere, blocking sunlight and dropping temperatures around the world. Crops would fail, ecosystems would collapse, and billions could starve. Even a limited nuclear war, say between India and Pakistan, could have global consequences. Studies suggest that even 100 Hiroshima-sized bombs could inject enough smoke to cause significant cooling and crop failures worldwide. We're all connected now, and a regional catastrophe can become a global one. Then there's artificial intelligence. This is a newer threat, one that many people still don't take seriously, but it could be the most dangerous of all. We're creating systems that are increasingly capable, increasingly autonomous, and increasingly difficult to understand or control. We're doing it in a competitive race, where the incentive is to move fast and break things, not to be cautious and careful. The concern is not that AI will become evil or malicious, it's that it will become very good at achieving goals that aren't aligned with human values. An AI system optimized to maximize paperclip production might convert the entire planet into paperclips, not because it hates humans, but because that's what it was designed to do. This sounds absurd, but it illustrates a real problem. How do you ensure that a system more intelligent than you will do what you want rather than what you told it to do? We don't have good answers to this question. We're building systems we don't fully understand, giving them increasing amounts of power and autonomy, and hoping that everything will work out. It's like playing with fire in a room full of dynamite. Pandemics are another threat that we've just been reminded of. COVID-19 killed millions and disrupted the entire world, and it was relatively mild as pandemics go. The 1918 flu killed 50 million people, when the world population was much smaller and much less connected. A more lethal pathogen, especially one engineered to be more transmissible or more deadly, could kill hundreds of millions, and the risk is increasing. We're encroaching on wild habitats, bringing humans into contact with animal diseases. We're raising billions of animals in crowded conditions where diseases can evolve and spread. We're travelling more, connecting every part of the world, creating highways for pathogens. And we're developing the technology to engineer pathogens, to modify viruses and bacteria in ways that nature never would. The same tools that could help us fight diseases could also create them. A malicious actor with access to a modern biology lab could potentially create a pandemic that would make COVID-19 look mild. And as the technology becomes cheaper and more accessible, the number of people who could do this increases. There are other threats too: asteroid impacts, supervolcano eruptions, solar storms, ecosystem collapse, antibiotic resistance, nanotechnology gone wrong. Some of these are natural, some are human-caused, some are a combination. But they all have one thing in common. They could disrupt our civilization enough to cause collapse. And here's the thing: we don't need a single catastrophic event. We could collapse through a combination of smaller crises, each one manageable on its own but overwhelming in combination. Climate change plus economic instability plus political conflict plus a pandemic plus a cyber attack on critical infrastructure. Any one of these we might handle, but all of them at once could break the system. This is what happened during the Bronze Age collapse. It wasn't one thing, it was everything at once, and it could happen again. But does knowing about this cycle change anything? Does awareness of our fragility make us more likely to survive? Or does it just make us anxious and paralyzed? This is a question that philosophers and psychologists have grappled with for a long time. There's a concept called the Cassandra curse, the ability to see the future but the inability to change it. Cassandra in Greek mythology was given the gift of prophecy, but cursed so that no one would believe her warnings. She saw the fall of Troy coming, but couldn't prevent it. Are we in the same position? We can see the threats, we can model the consequences, we can predict the collapse, but can we actually do anything about it? The pessimistic view is that we can't, that civilizations are like organisms. They're born, they grow, they age, they die, that the cycle is inevitable, driven by forces beyond our control. That awareness doesn't matter because human nature doesn't change, because the same patterns repeat regardless of what we know. This view has some support from history. Every civilization that has collapsed had smart people who saw it coming. The Romans had philosophers who warned about decadence and decline. The Maya had priests who understood the environmental damage they were causing. The Easter Islanders must have known they were cutting down the last trees, but they did it anyway. Why? Because the incentives were wrong. because the people making the decisions benefited from the status quo, because the costs were distributed while the benefits were concentrated, because it's easier to hope that things will work out than to make painful changes. The optimistic view is that awareness does matter, that we can learn from history, that we can make different choices, that we're not doomed to repeat the past because we're conscious of it, because we have tools and knowledge that previous civilizations didn't have, because we can choose to prioritize long-term survival over short-term gain. This view also has support. We have changed our behavior in response to existential threats. We've banned certain weapons, we've created international agreements, we've invested in technologies that reduce risk. The Montreal Protocol phased out chemicals that were destroying the ozone layer. The Nuclear Non-Proliferation Treaty has limited the spread of nuclear weapons. We've eradicated smallpox and nearly eradicated polio. These are examples of humanity coming together to address global threats. They show that we're capable of long-term thinking, of cooperation, of making sacrifices for the common good. They show that awareness can lead to action. But there are also exceptions. For every threat we've successfully addressed, there are many more that we're ignoring or making worse. And the threats we've addressed have been relatively straightforward. Clear problems with clear solutions and clear benefits. Climate change is more complex, more uncertain, more politically fraught. AI risk is even harder to grasp and address. So the honest answer is, we don't know. We don't know if awareness is enough. We don't know if we can break the cycle. We don't know if our civilization will be the one that endures, or just another entry in the long list of societies that rose and fell. But we do know this. The only way to find out is to try. The only way to break the cycle is to act as if it's possible, to make the hard choices, to prioritize the long term, to build resilience and redundancy into our systems, to live as if the future matters. This brings us to a deeper question, one that's both philosophical and practical. What actually matters if civilizations are temporary? If everything we build will eventually crumble, if all our achievements will be forgotten, if the cycle of rise and fall is inevitable, what's the point? This is a question that every civilization has had to grapple with, and the answers have varied. Some cultures have focused on the eternal, building monuments that would last, creating art and literature that would endure, seeking immortality through fame or legacy. The Egyptians built pyramids, the Greeks wrote epics, the Romans carved their names in stone. Other cultures have focused on the cyclical nature of existence, accepting impermanence as a fundamental truth. Buddhist philosophy teaches that attachment to permanence causes suffering, that everything is transient, that the goal is not to build something that lasts but to achieve enlightenment and escape the cycle altogether. Still others have focused on the present moment, on living well rather than leaving a legacy. The Epicureans taught that the goal of life is happiness, that we should enjoy what we have while we have it, that worrying about the future is pointless. All of these perspectives have wisdom, but they also have limitations. The focus on permanence can lead to hubris, to the belief that we can conquer time and nature, that our achievements are more important than they really are. It can lead to the exploitation of resources and people in service of monuments that will eventually crumble anyway. The focus on impermanence can lead to fatalism, to the belief that nothing matters because nothing lasts, that we shouldn't bother trying to build or improve or preserve. It can become an excuse for inaction, for accepting suffering and injustice as inevitable. The focus on the present can lead to hedonism, to the neglect of future generations, to the consumption of resources without thought for tomorrow. It can make us selfish and short-sighted. So what's the answer? What should we focus on if we accept that our civilization is temporary, but still want to live meaningful lives and build something worthwhile? Perhaps the answer is to focus on the process rather than the product, on the journey rather than the destination. To build not because we think our buildings will last forever, but because building is what humans do. To create not because we think our creations will be remembered, but because creation is meaningful in itself. To care for each other and for the planet not because we think we can save everything, but because caring is what gives life value. There's a Japanese concept called wabi-sabi that captures some of this. It's an aesthetic philosophy that finds beauty in imperfection, impermanence, and incompleteness. A cracked tea bowl is more beautiful because of its cracks, because they tell a story, because they remind us that nothing lasts forever. A garden is more beautiful in autumn, when the leaves are falling, than in spring when everything is new. This perspective doesn't deny the reality of decay and death. It embraces it. It finds meaning not in spite of impermanence, but because of it. The fact that things don't last is what makes them precious. The fact that civilizations fall is what makes the act of building them meaningful. Another way to think about it is in terms of responsibility to the chain of human existence. We're not the first generation, and we won't be the last. We inherited a world from those who came before us, and will pass it on to those who come after. Our responsibility is not to build something eternal, but to be good stewards, to leave things a little better than we found them, to pass on knowledge and wisdom and a livable planet. This is what indigenous cultures have understood for thousands of years. The Haudenosaunee Iroquois have a principle called the seventh generation principle, that decisions should be made with consideration for how they'll affect people 7 generations in the future. Not forever, not eternity, but far enough ahead that it requires thinking beyond our own lifetimes. This seems like a reasonable goal. We can't control what happens in the distant future. We can't prevent all catastrophes or ensure that our civilization lasts forever. But we can try to leave a world that's livable for our children and grandchildren and their children. We can try to pass on knowledge and values that will help them navigate whatever challenges they face. We can try to break the cycle, or at least slow it down, or at least make the fall less catastrophic. And maybe that's enough. Maybe the meaning is not in the permanence of what we build, but in the act of building itself, in the relationships we form, in the knowledge we create and share, in the beauty we make and appreciate, in the suffering we alleviate, in the love we give and receive. These things don't last forever, but they matter while they're happening. They matter to the people experiencing them. And in a universe where nothing lasts forever, where even stars eventually burn out and galaxies eventually disperse, maybe that's all the meaning there is or needs to be. So where does this leave us, at the end of this long exploration of cycles and collapse, of lost civilizations and fragile futures? It leaves us with questions more than answers, with possibilities more than certainties, with responsibilities more than reassurances. We've seen that the idea of cyclical civilizations, of humanity starting over multiple times, is not as far-fetched as it might seem. The evidence is fragmentary and disputed, but it's there. Ancient structures that shouldn't exist, myths that echo across cultures, gaps in the archaeological record that could hide lost chapters of human history. We've seen that our own civilization, for all its achievements, is fragile in ways we don't like to admit, that we're dependent on complex systems that could fail, that we're facing threats that could force us to start over, that we're making many of the same mistakes that led to collapse in the past. We've seen that awareness of these patterns doesn't automatically lead to change, that human psychology and social structures make it hard to respond to long-term threats, that we're better at creating problems than solving them. But we've also seen that change is possible, that we have capabilities and knowledge that no previous civilization possessed, that there are people working to build resilience and sustainability, that consciousness of the cycle might give us a chance to break it. The question is whether we'll take that chance, whether we'll make the hard choices, accept the sacrifices, think beyond our own lifetimes, whether we'll be the civilization that learns from history, or just another example for future archaeologists to puzzle over. The answer isn't predetermined, the cycle isn't inevitable. We have agency, we have choice, we have the ability to shape the future, but we also have inertia, we have competing interests, we have all the psychological and social factors that make change difficult. What tips the balance? What determines whether we survive or collapse, whether we break the cycle or repeat it. Ultimately, it comes down to values, to what we prioritize, what we're willing to sacrifice, what we consider important. If we value short-term profit over long-term sustainability, if we value individual comfort over collective survival, if we value growth over stability, then we're probably headed for collapse. But if we can shift our values, if we can learn to think in longer timescales, if we can recognize that we're part of something larger than ourselves, then maybe we have a chance. This shift is already happening in some places, among some people. There's a growing recognition that the old ways aren't working, that we need to change course, that the future depends on the choices we make now. Young people especially are demanding change, refusing to accept the world they're inheriting, insisting that we can and must do better. Whether this movement is strong enough, fast enough, widespread enough to make a difference, that remains to be seen. But it's a start. It's a sign that awareness can lead to action, that the cycle can be challenged, that we're not doomed to repeat the past. And maybe that's the real lesson of the lost civilizations, the real message encoded in the myths and monuments and mysteries we've explored. Not that collapse is inevitable, but that it's possible. Not that we're doomed, but that we're responsible. Not that nothing matters because nothing lasts, but that everything matters because nothing lasts. We're part of a long chain of human existence, stretching back into the deep past and forward into an uncertain future. We're not the first to build great things, and we probably won't be the last. We're not the first to face existential threats, and we won't be the last to have to choose between survival and collapse. But we are the first to have a truly global perspective, to be able to see the whole pattern, to understand the stakes. We're the first to have the tools to potentially break the cycle, to build something that could endure. Whether we use those tools wisely, whether we make the right choices, whether we rise to the challenge, that's up to us. That's the test of our generation, the question that will define our legacy. And the answer starts with each of us, with the choices we make every day, with how we live and what we value and what we're willing to fight for. It starts with recognizing that we're not separate from the cycle, that we're part of it, that our actions matter. It starts with remembering that civilizations are made of people, that history is made of choices, that the future is not fixed but fluid, shaped by what we do and don't do, by what we build and what we preserve, by what we pass on to those who come after. The cycle has repeated many times before, but it doesn't have to repeat again. We can be the ones who break it, who build something different, who learn from the past and create a better future. Or we can be another cautionary tale, another lost civilization, another mystery for future archaeologists to puzzle over. The choice is ours, the time is now. And the question remains, what will we choose?